Okay, so now let's work a little bit on these exercises, exercise 9.2. And so the exercises are, so we have exercise 9.2. Question number 1, we have find the sum of odd integers from 1 to 2001. You want to find the sum of odd integers from 1 to 2001. From 1 to 2001. So odd integers from 1 to 2000. So of course you know that 1 is an odd number, right? So that means that you would have, and 2001 is also an odd number, meaning that the numbers would be 1, basically 3, 5, 7, and so on and so forth, all the way up to 2001, right? Now, the number of the sum of these numbers, this is of course an arithmetic progression, because your first term is 1 and your common difference is 2. 1 plus 2 is equal to 3, 3 plus 2 is equal to 5, and so on and so forth. And in the case of an arithmetic progression, we said that basically you can use the formula S of n is equal to n divided by 2 times 2a plus n minus 1 times d, and you can also use S of n is equal to n divided by 2 times a plus l. If you want to use this formula, you need to have your n, which is basically the number of these numbers, the number of these terms, and the first term, which is a, and the common difference. If you want to use this formula, then d is not there, meaning that you need to know the number of those numbers, the number of those terms, plus the first term plus the last term. But then you don't have to use the common difference, but which is not a problem here because we already have the common difference. So we can just simply use this formula right here. But we need to know how many terms we have here. In order to calculate that, you know that a of n is equal to basically a plus n minus 1 times d. That gives you the nth term. Now if I set the nth term as 2001, and basically the first term, call it 1 basically, which is 1, and then write over here n minus 1, and your d is equal to 2, and that way you will get what you will have is basically which term 2001 is, or in other words, you will basically know how many terms this arithmetic progression has, because 2001 is the last term, right? So suppose that you get, for example, n is equal to for example, I don't know, 2000, for example, right? Or it would be less than this, because the number of these numbers is basically half the number of natural numbers from 1 to 2001, and you're going from 1 to 2001, so that means that the number of those numbers is essentially 2001 numbers. 2001, if you divide that by 2, you will get 2001 divided by 2, but it should be something either 1001 or 1000. We will find out what that is. It must be one of these two numbers, right? Now suppose that I get my n as, for example, 1001. Not this one, but n is equal to 1001. So that means that basically a of 1001 would be equal to 2001. Right? Which means that 2001 is the 1001th term, and then since 2001 is the last term, that would mean that then basically the arithmetic progression has 1001 terms, right? So then we can calculate our basically n over here, which is 2001, is equal to 1 plus 2n minus 2, and 2001 is the same thing as 2n minus 1, and 2n is equal to basically 2002. 2001 plus 1 is equal to 2002, which means that n is equal to 2002 divided by 2, which is equal to 1001, right? This basically means that a of 1001 is equal to 2001, which means that 2001 is the 1001th term, right? The 1001th term, which means that then this arithmetic progression has 1001 terms, right? Now that we know the number of terms, we can calculate s of basically s of 1001 is equal to 1001 divided by 2 times 2a, which is basically 2 times 1 is equal to 2, plus n minus 1, which is 1000, times d, and d here is equal to 2. And then you can take a 2 out from here, so you can write 1001 divided by 2 and write it as 2 times 1 plus 1000, right? 2 times 1 plus 1000, and then you can cancel these two out, and so you have 1001 times 1001, which is the same thing as 1001 squared. So 1001 squared is the same thing as well, 1001 times 1001. So that's 1001, 0, and then another, so you would get all zeros here, and then another 0 for this, and then you would get a bunch of zeros there, and then another 0, and then you can multiply 1001 again here, so 1001. And then you have 1001, 2001. So 1001 squared is the same thing as 1002001. And that is the sum of the first, that is the sum of the odd integers from 1 to 2001. That is the sum of the odd integers. I think I need to restart my computer after this video. Odd integers from odd positive integers from 1 to 2001. Okay, so that was basically question number 1. Let me take a look at the answers here. 1002001. Question number 2. You want to find basically the sum of all natural numbers lying between 100 and 1000, which are multiples of 5. So the question is to find the sum of all natural numbers. The sum of all natural numbers lying between 100 and 1000, lying between 100 and 1000 and 1000, which are multiples of multiples of 5. So that basically all the natural numbers lying between 100 and 1000. So I suppose 100 and 1000 themselves are not a part of these numbers, meaning that the numbers have to be between these two numbers, right? So a multiple of 5 times 20 is equal to 100, right? 5 times 20 is equal to 100, but 100 is not, I suppose it's not supposed to be a part of our numbers. And 5 times 21 is equal to 120, 100 is equal to 100 and 105. 5 times 22 is equal to, 5 times is equal to 10, 1 and 11, that's 110. 5 times 23 is equal to basically 115, right? 15, 1 and 10, 11. And then you can go all the way up to 5 times 200, 5 times 200, which is equal to 1000. But 1000, as we discussed before, is not a part of our numbers here. So I have to go for 5 times 199. 5 times 199. Now 199 times 5 is equal to 5 times 9 is equal to 45, 4, 49, 4, and 995. That is equal to 995. That means that the list of numbers would therefore be starting from 105 going all the way up to 995. So you have 105, 110, 115, all the way up to 995. This is the list of the numbers that for which you want to find basically the number of them, right? I'm sorry, you want to find the sum of them, right? So again, what you can do is that you can use the formula S of n is equal to n divided by 2 times 2a plus n minus 1 times d, which means that I need to calculate the number of these numbers, right? So I can use the formula a of n is equal to a plus n minus 1 times d, and take my a of n as 995 is equal to 105 plus n minus 1 times d, which is equal to 5 here, because the difference between each two consecutive numbers is basically 5, right? So you have 995 is equal to 105 plus 5n minus 5, and that means that 995 is equal to 100 plus 5n, and that means that basically divide by 5 you will get 995 divided by 5 is equal to, well, 1 times 5 is equal to 5, 4, 9, 9 times 5 is equal to 45, and you get a 4, 45, and 9 times 5 is equal to 45, so that's 199, divide by 5, 199. Divide by 5, you'll get 20. Divide by 5, you'll get 1. And that means that n is equal to 199 minus 20, which is equal to 179. N is equal to 179. So this means that this doesn't directly mean that the number of these numbers is 179 or anything like that, but indirectly it means the same thing, meaning that what this means is that basically 995 here that I took as a of n here is a of 179. A of 179. And since it's the last term in this arithmetic progression, that means that the number of these numbers therefore becomes 179, right? So I can use the same number for the number of these terms in the arithmetic progression. So now I can calculate S of 179 here, S of 179 as 179 divided by 2, and write it as 2 times A, which is equal to 2 times 105, 2 times 105 plus n minus 1, which is 178 times 5, your d is equal to 5. which means that you have basically, you can take a 2 out here. You can write this as basically 2, no, basically you can write 179 divided by 2, take a 2 out, write this as 105 plus 175 divided by 2 would be basically 50, 35, and 4. That would be 85, 89, right? That would be 89 times 5. 89 times 5. And therefore you can cancel these two out, and then you can write this as 179 times basically 105. 89 times 5 is equal to 5 times 1 is equal to 45, and that's 44. That's 445. 445 plus 105 is equal to 0, 1. That's a 5, and that's a 5. 550. 550. And then 550 times 179, that's 55 and 0 there. You get 5 times 1 is equal to 45, 4. 5 times 1 is equal to 35, 39, 3. 5, and 8, 0. And the same number again, 5, 9, and 8. And then you will have basically 5, 14, 1, 18, and 9. And with a 0 over here, you will have 9, 8, 4, 5, 0. You will have 9, 8, 4, 5, 0, which is the sum of basically the sum of all natural numbers lying between 100 and 1000. 100 and 1000, which are divisible by 5. So I hope that the answer is correct. 98450. The answer is actually correct, meaning that the assumption that we made in the beginning was correct. Okay, so that was question number 2. Okay, so question number 3, we have in an AP, the first term is 2 and the sum of the first 5 terms is 1/4 of the next 5 terms. Show that 20th term is negative 112. So in this AP, basically your first term, this is question number 3, your first term is 2. A of 1 is equal to 2. And the sum of the first 5 terms, S of 5, is equal to, is 1/4 of the next 5 terms. Now, you need to basically do a little bit of calculation here in order to be able to write this in mathematical terms. Meaning that basically the statement is the sum of the first 5 terms, the sum of the first 5 terms, the first 5 terms is 1/4 of the next 5 terms. Is 1/4 of, I would assume that what they mean is 1/4 is 1/4 the sum of the next 5 terms. Okay, so we said that basically the sum of the first 5 terms is 1/4 the sum of the next 5 terms, 5 terms, and show that the 20th term, you want to show that the 20th term, I apologize for my handwriting, this is not actually me, this is the software writing for me, meaning that it's changing my handwriting. Show that the 20th term, a of 20, is equal to negative 112, right? Now, in order to basically to write this in mathematical terms, so the sum of the first 5 terms, of course, is s of 5, right? And the sum of that is equal to 1/4 the sum of the next 5 terms. So the sum of the next 5 terms would be, you cannot write, of course, s of 10 or s of 5 or anything like that, because this formula gives you the sum of the first n terms, right? Meaning that when I write s of 5, what that means is that a1 plus a2 plus a3 plus a of 4 plus a of 5 plus a of 5. Let me restart this software, because hopefully the problem is taken care of. So when I write s of 5, that means a of 1 plus a of 2 plus a of 3 all the way up to a of 5, right? Now the next 5 terms, that the whole series would be a of 1, a of 2, a of 3, a of 4, a of 5, a of 6, a of 7, a of 8, a of 9, and a of 10, for example, and so on and so forth. So we are saying that the sum of the first 5 terms, which is basically these terms together, s of 5, that is 1/4 of the sum of the next 5 terms. So the sum of the next 5 terms would be, if I call this s of 1, for example, now this 1 refers to, I would call it, for example, s of n, for example, s of capital N, for example, s of capital N, right? So to calculate this part, I have to calculate the sum of all of these terms. I have to calculate the sum of all of these terms, which is essentially s of 10, and then subtract from that s of 5 in order to get s of n, because I cannot directly get to s of n here. That means that s of n, which is the sum of the next 5 terms, that is equal to s of 10 minus s of 5. S of 10 minus s of 5. And we have the formula actually for this. We said that basically s of well, anyway, the formula, we don't really need it, but s of n would be, you could calculate it this way, right? So that means that s of 5, so now what we are saying here is that we are saying that basically this s of 5 is actually equal to 1/4 the sum of the next 5 terms, which is 1/4 s of n, which means that s of 5 is equal to 1/4 times s of 10 minus s of 5, which means that s of 5 is equal to 1/4 times s of 10. 1/4 s of 10, if I take s of 5 out, okay, 1/4 s of 10 minus 1/4 s of 5, right? And then you can put these together. You can write s of 5 plus 1/4 s of 5 is equal to 1/4 s of 10, and basically 4/4, so that's 5/4 s of 5 is equal to 1/4 s of 10, and cancel out the denominators. You can write 5 times s of 5 is equal to s of 10, right? So that means that is basically the meaning of this statement over here, right? And you know that a of 1 is equal to 2, right? So now I can rewrite this as, so we said that basically s of 5 times s of 5 is equal to s of 10, which means that 5 times s of 5 is equal to n divided by 2. So you know that basically s of n is equal to n divided by 2 times 2a plus n minus 1 times d, which means that basically this would be equal to 5 times basically n divided by 2, which is equal to 5 divided by 2 times 2a. Now your a is equal to a of 1, which is equal to 2. A of 1 is equal to 2. So that means that 2 times 2 is equal to 4. 2a plus n minus 1 times d plus 4 times d, right? That is equal to 5 times that. And that is equal to basically s of 10, which is n divided by 2, 10 divided by 2, times 2a, 2 times 2 is equal to 4, plus n minus 1, 9 times d. Right? So then you can cancel out these 2's, divide by 5, you will get a 2 here. So then you have basically 5 times 4 is equal to 20 plus 20d is equal to 8 plus 18d, which means that 20 minus 8 is equal to 18d minus 20d, which means that 12 is equal to negative 2d, which means that d is equal to 12 by negative 2, which is equal to negative 6. D is equal to negative 6. And so now your a is equal to a1, your a is equal to 2, and your d is equal to negative 6. You can use these in order to calculate s of a of 20. A of n is equal to a plus n minus 1 times d. So a of 20 is equal to a plus a, which is equal to 2, plus n minus 1, which is equal to 19 times negative 6. 19 times negative 6 is equal to 6 times 10 is equal to 60, 54, 114, negative 114, plus 2 minus s a of 20 is equal to this, which means that a of 20 is equal to negative 112. And therefore, that's what you wanted to show here, right? And therefore, this is basically proved. Okay, so that was basically that. And the next thing that we have is question number 4. Question number 4. Question number 4 is as follows. Okay, so question number 4, we have how many terms of the AP basically negative 6, negative 6, negative 11, negative 11 halves, and negative 5, and so on and so forth, are needed to give a sum of negative 25, meaning that s of n is supposed to be equal to negative 25. How many terms are needed? So you know that s of n is equal to n divided by 2 times 2a plus n minus 1 times d, and that would be equal to, so if s of n is equal to negative 25, then you would have n divided by 2, which is basically, n divided by 2 is basically, n divided by 2, you don't know what n is, you know what a is, it's negative 6, so that's negative 12, 2 times negative 6 is negative 12, n minus 1 times d. Your d is basically, you can find it by basically your first term over here is negative 6, and if you add a d to that, you'll get negative 11 halves, right? Which means that d is equal to negative 11 halves plus 6, which is equal to 2 negative 11 plus 12. 12 minus 11 is equal to 1, that's 1 half, right? And if I add a 1 half to negative 11 halves, negative 11 halves plus 1 half. Okay, I apologize for the phone call. So negative 11 halves plus 1 half is equal to negative 11 plus 1 is equal to negative 10 halves. Negative 10 halves. This is equal to negative 5. Yeah, which is equal to negative 5. So you can see that your basically your d is equal to 1 half, right? So your d is equal to 1 half, which means that basically, so if your d is equal to 1 half, so we wanted to know how many terms we have to add together in order to get negative 25. So now multiply by 2, you'll get negative 50 is equal to n times, for example, n times negative 12 plus 1 half n minus negative 1 half. Now negative 12 negative 1 half is negative 12 and a half, right? Negative 12 and a half is the same thing as 24, negative 25 halves, right? So negative 25 halves, negative 25 halves, and you have plus 1 half times n, and you have that as n is equal to basically negative 50. Now I can take a negative, a 1 half out, meaning that I can write this as n divided by 2 times negative 25 plus n, and write this as negative 50. Again, multiply by 2, you will get negative 100 is equal to n times negative 25 plus n, which means that negative 100 is the same thing as negative 25n plus n squared, which means that n squared negative 25n plus 100 is equal to 0, and then you need to solve this equation. Which means that basically 4 times 100 is the same thing as 4 times 25, right? 4 times 25, which is not going to be, or 2 times 50. Let me see. So if you write 100, 2 times 50, 2 times 25, 5 times 5. So if you add basically negative 25 you have here. So you have 10 and 10, so you have 25 times 2 is equal to 50. How do I write 100? Let's see if that's all correct. So over here we had S of n is equal to n divided by 2 plus 2a plus n. So negative 25 is equal to n divided by 2 plus basically 2 times a is equal to negative 12 plus n minus 1 times 1 half. So negative multiplied by 2, negative 50 is equal to n times negative 12 plus 1 half and negative 1 half. Negative 12 minus 1 half is equal to negative 12 and a half, right? Which is the same thing as negative 24, 20 plus 1 is equal to 25 halves. So you have negative 25 halves plus 1 half n take your 1/2 out, you'll get negative 25 plus n, and then multiply by 2, you will get basically negative 100 is equal to negative 25, and so then you have negative 100 is equal to that, so negative 100 is equal to negative 25n plus n squared. N squared negative 25n plus 100 is equal to 0. The equation is correct. But it seems that there is no way to actually, or you can write this as 25/4 let me see. Okay, so I couldn't actually get the numbers, but I had to cheat. It turns out that the numbers are, of course, it's easy to see. I didn't see that really. So you have 4 times 5 is equal to 20. 20 times 5 is, of course, equal to 100. It's very easy. My mind was not really working at the time. So 25 times 5 is equal to 100, right? And if I take negative 20 and negative 5, add them together, I'll get negative 25, multiply them together, I'll get positive 100, which is basically what I'm looking for, right? So I write this as n squared, negative 20n, negative 5n plus 100 is equal to 0. And then you can write this as basically n times n, take these two terms together, you get n times n minus 5, negative 20 times n minus 5 is equal to 0, which means that n minus 20 times n minus 5 is equal to 0, which gives me n negative minus 20 is equal to 0, or basically n minus 5 is equal to 0, which means that n is equal to 20 or n is equal to 5. And both the answers are most probably correct because as you can see here, this is an arithmetic progression. The more that you write terms, add terms to this arithmetic progression, basically you will reach to a point where you will get to positive terms, meaning that you start with negative 6 and your common difference is 1/2. That means that if you have 12 terms over here, you will reach to 0, and then the terms become positive, and then the positive terms and negative terms will cancel each other out, and which is basically 20 here, and then the value of the sum becomes negative 25. On the other hand, if you add only 5 of them together, in that case also you will get a negative 25, which means that you can actually accept both of these answers. Now let me actually check over here. Number 4 is basically, it seems that only, both of them are actually correct, right? Both of them are correct. Okay, so that was question number 4. Now question number 5 is in an arithmetic progression. If the pth term is 1 over q and the qth term is 1 over p, prove that the sum of the first p times q terms is basically 1/2 times that. So basically that's question number 5, which is in an arithmetic progression. If the pth term is basically 1 over q, and the qth term is 1 over p, prove that prove that the sum of the first p times q terms, that the sum of the first p times q terms is 1/2 times pq plus 1, where p is not equal to q. So now to solve this problem, basically we have in an arithmetic progression, the pth term is 1 over q. That means that a of p is equal to 1 over q, and also that the qth term, a of q, is equal to 1 over p, right? Now we want to prove that basically that the sum of the first p times pq terms, s of pq, is equal to 1/2 times pq plus 1, where p is not equal to q, right? So let's see how we can solve this problem. Okay, so to solve this problem, basically what you can do here, the solution here is not very straightforward. You have to get the information that you need from different places and then put them together. I had to do this once on my own to first understand how this solution works. But it's not complicated at all. It's very easy. So essentially what you will do, you have to calculate, basically to calculate s of pq, you need to know, basically you know that s of n is equal to n divided by 2 times 2a plus n minus 1 times d, right? So you need to calculate basically your a and d. You need to calculate your a and d from the information that you have from here, and then calculate s of pq based on this formula, which is basically as follows. So if you calculate basically based on the information that I have here, I can say that a of p, you know that a of n is equal to a plus n minus 1 times d, which means that a of p is equal to basically a plus p minus 1 times d, which is equal to 1 over q. You can call this equation number 1, for example. Moreover, you can say that a of q is equal to a plus q minus 1 times d, which is equal to 1 over p, based on this here. You can call this equation number 2, and now if I subtract 2 from 1, we have, this is to calculate your d, basically. So then you can say that a plus p minus 1 times d minus, and subtract from that number 2, which is minus a plus q minus 1 times d is equal to 1 over q minus 1 over p, right? And that you can write as a plus p minus 1 times d minus a minus q minus 1 times d is equal to 1 over q minus 1 over p. And then you can write this as a plus p minus 1 times d minus a, and so you can cancel basically the a's and a's, you can cancel out, meaning that a and a you can cancel out. And then what you can do is that, of course, you can take the d out from these two, write it as d times p minus 1 minus q minus 1 minus q minus 1 is equal to, basically add these together, these two together, 1 over q minus 1 over p is equal to p times q, and there you would get p minus q. So you have basically p times q and p minus q there. And then you can write this as d times p minus 1 minus q plus 1 is equal to p minus q over pq, and d times p minus q plus p minus q, because these two you can cancel out, is equal to p minus q over pq. P minus these two you can cancel out, d is equal to 1 over p times q. So once you have your d, you can use your d in for example in 1. You can use your d in 1 to give you basically a, meaning that you can write a plus p minus 1 times 1 over pq, d is equal to 1 over pq is equal to 1 over q. And so a is equal to 1 over q minus p minus 1 times 1 over pq I don't remember how I actually did this. A plus p minus 1 times 1 over p, so is equal to I think if you write this as basically, if you write this as basically 1 over q minus p minus 1 over pq, and then write this as basically pq, and then you have p minus 1, and then write this as basically p minus p plus 1 over pq, and that's a is equal to 1 over pq. So that is basically your a, and so your d is equal to 1 over pq, and your d is equal to 1 over pq. And now what you can do is that you can write s of, you know that s of n is equal to n divided by 2 times 2a plus n minus 1 times d, which means that s of pq is equal to pq whole divided by 2 times A is equal to 1 over PQ, so 2 times 2 over PQ plus n minus 1. N minus 1 would be PQ minus 1. PQ minus 1 times D is equal to 1 over PQ over here. 1 over PQ. And so you have basically PQ divided by 2 times 2 over PQ plus PQ over PQ is equal to 1 minus 1 over PQ now 2 over PQ minus 1 over PQ is 1 over PQ, so that's PQ divided by 2 times 1 over PQ plus 1, and then you will have basically multiply these two together, you get 1 by 2 plus PQ over 2. That's S of PQ. And we wanted to show that you can take a 1/2 out, 1/2 times 1 plus PQ. That is S of PQ. That's what we wanted to show. Okay, so that was question number 5. A little bit unusual question, but well, it's mainly algebra. Question number 5 we will do, question number 6 we will do in the next video. Thank you.